All right, hello and welcome. In this example, we're going to look at how to convert degrees to radians. So I got 3 degree numbers here. We're going to convert each of these here. And I also pulled out the unit circle over here. And so this compares a bunch of these values and kind of gives you an idea of where they fall together. So in the middle here, we see that these are all of our degrees. We go from 30 all the way around. It comes back up here to 0, which is equivalent to 360. That's a full circle rotation, right? We see 180s on the other side here. That's a flat line, right? So each one of these degrees is paired with a radian value. And so we can convey this angle of 30 degrees as 30 degrees, or we can say that it's pi over 6. And that's going to be the same thing, but just radians, right? It's kind of like that 0.5 and 1/2 idea, right? They're both meaning the same thing, but they're slightly different conversions, different ways of identifying it. And then we can also identify the node out here, the circle the point that we've identified. And that point is an XY plot line, right? And so that's going to be the XY location of that. And if we know the XY, we can determine what the angle is, and we can determine that in radians or in degrees. And so we'll use all of these in conjunction with a bunch of other different calculations that we're doing. So in the following angles, we are going to convert them to radians. We have a 27 degrees here, and so we can say that 27 degrees can be multiplied by our pi over 180. Right? And that's like comparing our line over here. Right? We're saying that there's pi number 1 pi in 180 degrees. And so that's going to give us a ratio equation for our degrees to factor into. And so we'll set this over here. And we actually want to make this equal to a pi value. We don't want to get rid of pi because pi is the thing that allows us to get extreme accuracy out of our numbers. That's why we use it. And so we're going to rearrange this one more time. We're going to say that we actually want 27 divided by pi, or 27 times pi divided by 180. All right, I just put the 27 on top right next to that pi. That way we have a division. We have 27 divided by 180, and that's technically the same thing. Right? If we were to calculate out the two different numbers, you'd be able to calculate both sections and have the same output. So we'll say 27 divided by 180, and we'll leave the pi off. Because if we leave the pi off, then we can actually get the ratio of these two, and we can factor it down without having to do too much effort. So if I put the pi in here, my calculator calculates the pi out. And I don't want it to do that. So I'm going to leave it off of there. I'm going to know that it belongs on top of this equation. And whatever fraction I get out of this, I'm going to put pi on top. So this would be equal to 3 pi over 20. There we go. So we'll do the next couple here. Say that this one is 216. So we'll do the same thing. So 216 goes on top with our pi. We'll divide that by that 180 mark. And we'll set that equal to, and we'll calculate that out, ignoring the pi for now and placing it on top of this equation once we get our final fraction out. So 216, this is greatest common denominator that our calculator is doing for us here. So it makes it a little bit easier because otherwise we'd have to reduce this fraction by hand. And this one can convert it over. Once it has a decimal form, it can just flip it over. That's 6 over 5. 6 pi, right? That pi belongs on top over our 5 value on bottom. And that's the radians form of our 216 value here. So we'll do one more. This last one is 294. So we'll say 294 degrees pi over 180 degrees. And that's going to give us our output. And again, we'll keep that pi off of there for now until we get our final fraction. 294 divided by 180. And that gives us a decimal range. We'll flip it over and say that's 49 over 30. Right, and our pi goes on top of that, right next to that 49. All right, let us know if you have any other questions.